The problem is temperature control in a community building in Southern California. The Topanga Community House can become uninhabitable during the summer months. This stops events like feeding the seniors during July and August. This monthly event brings all the local senior citizens in the community together for a home-cooked meal by volunteers. The brick building was made in 1960 and is 3,300 square feet and has a capacity of 300 people. The optimal temperature for comfort will be 76 degrees Fahrenheit. The problem is to find the best technical, economic, and environmental solution to prevent the Topanga Community House from exceeding 76 degrees. The main constraint for this problem is the lack of space in and around the building. The next is the financial limitations of a nonprofit organization. The objectives for this project are study ways to cool, measure the constraints, analyze different systems, select the best option, and then design the system around that. The literature review was helpful in finding the optimal temperature, which is 76 degrees Fahrenheit, and alternatives to cooling. The method used in this project follows one similar to the define, measure, analyze, improve, and control process, otherwise known as DMAIC. First is to define the problem statement. From that, it is necessary to gather information. For this particular project, the main information needed is on the different methods of cooling. This includes the effectiveness, lifespan, and cost of each of the 4 types of cooling systems: air handler and condenser, package, mini split, and swamp coolers. In addition to mechanical systems, non-mechanical ones need to be researched as well. This includes vegetation, awnings, and insulation. Also, information can be gathered about possible future technology. Next is the information about the Topanga Community House. Besides the building specifications, this would be the current cost of rental and projected cost with air conditioning. The present-day regulations need to be investigated as well, so no environmental or human regulations are violated. The recorded temperature for the region is also necessary to determine the difference between having and not having air conditioning. Lastly, would be to gather information on the building's use and ones similar to it. The next step in the process is measure. There are 2 parts. The first is to calculate the BTUs, which would dictate the tons necessary to cool the building. The data needed to calculate this are the building dimensions and capacity. The second is to measure the temperature at the community house. This would be compared to the recorded temperature to check for accuracy. Then the projected temperature could be calculated. After measure comes analyze. However, there would be one step before, which is to generate alternatives. Instead of analyzing all the possible options, the best few will be chosen for analysis. There are 2 different categories under which the options will be analyzed. The first would be a technical analysis. This would include the speed of cooling and physical abilities of the equipment or system. The second would be a more in-depth cost analysis. The different inputs would be lifespan, equipment cost, energy efficiency, and consumption, installation, maintenance, and environmental impact. Once the analysis is done, the best system can be chosen for design. Then the locations for any outdoor and indoor equipment will be marked on plans. After the design is done, the plans for implementation can be done. This would include how long the system will take to install, how much it will cost, how it will be financed, and if there is any operational training necessary to run it. Last is the final recommendations based on the previous sections. This will elaborate on the implementation plan and explain the benefits of going through with the installation.